Sorry. Assalamualaikum and good day. Today we will be presenting about cutlery manufacturing process. Our teammate is Muhammad Hanif Muhammad Akbar. Second, me myself, Yusrina Nur Akilah. Third, Nur Azrin. And lastly, Muhammad Aiman. And we are from 1 BMCG Section 5. Alright. We will be covering about introduction, manufacturing process, assembly process or packaging, manufacturing issues or aspects, conclusion, reference, and appendix. First, introduction, I'll be talking about cutlery. Cutlery includes any hand implements used in preparing, serving, and especially heating food in the Western world. The spoon was one of man's earliest inventions, possibly as old as the custom of drinking hot liquids or water. A person who makes or sells cutlery is called a cutler. The city of Sheffield in England has been famous with the production of cutlery since the 17th century, and a train, the Master Cutler, running from Sheffield to London was named after the industry. Cutlery is usually known as silverware or flatware. And lastly, the major items of cutlery in the Western world are the knife, fork, and spoon. Next, stainless steel cutlery and main characteristics. Stainless steel cutlery features: first, food grade raw material, healthy and shafty, mirror polishing for easy cleaning. The main characteristic first is weldability. The requirement for welding performance vary from product to product. A type of tableware generally does not require welding performance and even includes some pot enterprises. However, most products require good welding performance of raw materials such as second-class tableware, vacuum flasks, steel pipes, water heaters, water dispensers, etc. Second, corrosion resistance. Most stainless steel products require good corrosion resistance, such as Class 1 and Class 2 tableware, kitchen utensils, water heaters, water dispensers, etc. Some foreign businessmen also conduct corrosion resistance tests on products. Use natrium chloride, a aqueous solution from warm to boiling after a period of time. To drop the solution, wash and dry weight the weight loss to determine the degree of corrosion. And lastly, heat resistant. Heat resistant means that stainless steel can maintain its excellent physical and mechanical properties at high temperature. And next, raw material. The raw material of silverware is stainless steel, sterling silver, or in the case of silver plate, a base metal over which a layer of silver is electricity deposited. Second, stainless steel is a combination of steel, chromium, and nickel. Third, the finest grade of metal used in production quality lines is 18/8 stainless steel. This means that it contains 18% chromium and 8% of nickel. Fourth, stainless steel is very popular because of its easy care, durability, and low price. And last one, silver plate is the result of a process that bonds pure silver to a strong base metal. The resulting tableware is durable, has the look and feel of silver, but is much less expensive than sterling.
Okay, my name is Hanem Muhammad Akbar. Next, I will discuss about manufacturing process for cutlery. Okay, manufacturing process have a have a nine steps. First, blanking, rolling, annealing, cutting to outline, forming the pattern, special step, silver plating, buffing, and sand polishing, and lastly, quality control. Okay, first, blanking. Production begins with rectangular flat blanks of stainless steel, sterling, silver, or in the case of plate, flatware, and alloy. Last roll are stamped in individual blanks which are flat piece, roughly the same shape as the piece to be produced. Rolling. Through a series of rolling operations, these blanks are graded or roll to the crack thickness and shape required by the manufacturer's flatway patterns. First, the blanks are rolled crosswise from the left to the right, right to the left, and lengthwise, then trimmed to outline. Each spoon, for instance, must be thick at the base of the handle to resist bending. This gives great pieces the right balance and a good feel in the hand. This piece is now in the form of a cleanly finished shape in the rough dimension of the utensil. Annealing. Between operation, the blank must pass through annealing oven to soften the metal for future machine operation. The annealing done under great heat must be very accurately controlled, so the final piece will be resistant to bending and to nick and then when is used. The last annealing is the most important because of the piece must be the right degrees of hardness when they are embossed. Then the metal can be forced easily into all the tiny details in the dies and the ornamentation will be faithfully reproduced. Cutting to outline. The roll blanks are placed in the cut or pressed by an operator to remove the excess metal and to fashion the shape of the piece. This process is similar to cutting shape from roll dough. The shape of the piece is cut out of the metal and the excess metal is removed and transformed back into sheet of metal to be used again. This trimming must ensure an accurate fit of the pieces into the dies when the design is applied. Forming the pattern. The next step is the forming of the pattern. Each pattern has its own hardened steel dies, two dies for each piece. First, one with the pattern for the front of the piece, and the second is the other one with the pattern for the back of the piece. These are carefully set in the hammer by die setter. The operator quickly places a piece in place under the drop hammer with descent with a hydraulic pressure of 200 times. The metal is squeezed into every tiny detail of the ornamentation in the die, embossing the pattern on the piece. The blow of the hammer hardens the piece for use in the home. The plus metal around the outline of the piece is removed by clipping press. Okay, special steps are necessary for the creation of knife, spoon, and fork. To make the hollow handle for the knife after two strips of metal are formed to shape, they are then soldered together, buffed and polished until the seam is no longer visible. The blade and handle are permanently joined by means of a powerful cement which bonds with a great strength and durability. With the spoon, after the pattern has been embossed, open the front and back of the handle. The next step is the forming of the bowl. The forming is done again under the same powerful drop hammers from accurately steel dies. This will require two hammer blows. The plus metal around the outline of the spoon is removed by clipping press. The forming of fork lines is a similar process to that of the forming of the spoon bowl, but the operation takes the place before the pattern is applied to the handle. After a fork is cut to outline, it is pierced and thin. The line are pieced out and the small piece of metal that hold the tip of the tin together is removed in another operation after the pattern has been applied. Silver plating. For the silver plate piece, the electroplating process is an additional step. The pieces are first prepared by being buffed so that the edges are smooth and the surface are free from small holes. When the buffing is complete, the pieces are given a thorough cleaning with as many as 12 different chemical solutions. Finally, they undergo electrolysis in which a layer of silver is electrically deposited over the base metal. Buffing and sun polishing. The knife, fork, and spoon are now buffed and polished. Depending on the pattern, the special finishing process can give silver plate and sterling silver piece a bright mirror-like finish, a soft, satiny glow, or a brush. And last one is quality control. Final inspection check the pieces for burrs, scratches, rough polishing, quality between pot stain, discoloration, or any other flaws that might have could occur when the pieces were stamped, shaped, and polished. Okay, let's see the video for cutlery process. Yes, sound.
Kenapa?
Tak ada bunyi suara ya?
Tak dengar ke?
Tak ada suara.
Tak ada. Sekejap Aku stop presenting kejap.
Memang kena edit.
Cuba kau cakap balik yang video tu.
Aku cakap apa ya tadi?
Let's see the video.
Okay. Okay, let's see the video for cutlery process.
Humans have been making eating utensils since prehistoric times. Sterling silver flatware remained the norm for centuries. But since the 1950s, stainless steel flatware has been the metal of choice. Stainless steel flatware is preferred by many because it's durable and doesn't tarnish over time. It all begins with a thick coil of wire. To make knives, a heading machine cuts the coil into blank pieces with a head at
This
one
is
end.
knife process.
This head is called a bolster. It will connect the blade to the knife handle. A furnace softens the metal so it can be shaped in a forging press. A series of dies progressively shape the metal. After grinding the end of the bolster flat, the next machine welds on the tang. The tang fits inside the knife handle. An automated grinding wheel tapers the blade thinner at the front. A second grinding wheel scallops the front edge. This is the knife serration. The thicker back end gives the blade strength to withstand the pressure you apply when cutting food. The factory uses stainless steel with a higher nickel content for the knife handles. It has greater corrosion resistance and is easier to form. This is critical because the handles often feature intricate designs. Each forged knife handle piece starts out as half a handle. A spot welding machine tacks the two halves together, forming a complete handle. To fuse the halves completely, this machine cuts a piece of copper-based wire and drops it inside the hollow handle. A furnace melts the wire so that it flows into the crevice between the two halves, soldering the seam thoroughly. An edging machine grinds the solder line until it blends in with the surrounding stainless steel. Workers pour liquid cement into the center of a carousel on which they mount 50 handles at a time. As the carousel spins, the centrifugal force shoots the cement outward, filling the handle cavities. Then workers insert a blade into each one. A 10-minute soak in hot water cures the cement. Workers scrub off any excess cement that oozed out. On the spoon line, a press cuts stainless steel into paintbrush-shaped pieces. Then, heavy rollers stretch those pieces out, thinning the end that will become the spoon's bowl. A trim press cuts the spoon's profile. Next, a machine called a coining press punches a pattern into the handle, then forms the bowl to its rounded shape. Forks go through the same steps as spoons before going into a press that cuts the tines in 2 stages. A support bar keeps the tines from moving, while a coining press puts a slight bend in them. The next machine slices off that bar and stacks the finished forks. The last stop for all the flatware is the buffing equipment. Cloth wheels polish the surface with a liquid buffing compound until the steel shines. The casual flatware are now ready for packaging. The more formal ones get dressed up with full or partial plating in silver or gold.
Next, ni Pak
Alright.
Azrina.
Okay, so I'm Nazmiti Mansur. You continue about assembly process and packaging. Alright, so spoon and fork process. Right, first thing first, stainless steel is the purchase in both sheet from a roll form. Next, the steel is cut into the smaller piece depending on the size of the cutlery that it will be used for. Next, after the stainless steel is cut to size, it goes through a blanking process which cut out the basic outline of the piece. Then, once they cut to outline, the bowl area is the roller thinner between 2 steel drums. The area is called a ball on the bowl, the spoon, and the fork. Next, after the next operation, they form the shape of the handle in the press using 2 steel die. After forming the handle, the excess material is the trim of the bowl area. After the bowl of trim, fork will go and have the thin cut off. Press polishing the bowl and the edges is the next operation in the process for bowl, spoon, and fork. Alright, next. After pre-polishing the bowl and the edges, the bowl shaped in the crate using a 400-ton press. Once the bowl are formed, force will have the inside of the tine around the remove any roughness and burst. Next, the edges, form and back of the piece are polished and give a final mirror finish. After the cutlery is polished, it is put into the ultrasonic soap and water wash machine to remove any excess polishing compound. Next, once cleaning, the piece are inspected and any defect piece and removed and sent for repair. After inspection, the good piece are packaged and ready to shipment. Alright, so next is knife manufacturing process. Alright, so first, knife manufacturing is slightly different than spoon and fork. The material is cut into the narrow piece. The pieces are then heat process that use coal and electricity. Once heated, they go through a frigging hammer where the shape is put into the handle. After the handle is formed, the roll and the other end of the piece flat to make the blank. Next, the excess material from the forging operation is then trimmed off of the handle. The blank is then trimmed to make the final shape of the knife. The knife are then pre-polished using wheel that are coated in with a fine grit sand. Next, the handle is then fully forming using a 400-ton press. The knife are then loaded into the furnace to handle the blank and handle. After handling, the knife go through the grilling operation that put a temper on the blank. The edges of the handle are then ground to remove any roughness. That's the blend are then pre-finished to remove most of the defect before finish polishing. Next, the serration or cutting edge is put into the blend at next operation. After the serration is done, the blend are then pre-polished one more time. Then the edges of the handle then cut a final finish using machine with a cut wheel. Finally, the piece of through the finishing line where they are give a mirror finish. After final polishing, the piece are inspected for defect and a good piece are placed into a plastic bag. After inspection, the knife are sent to have a company logo, age, the blend, and finish to shipment. That's all for me.
My name is Muhammad Aiman. I will present the manufacturing issue or aspect. The manufacturing issue or aspect is poor polishing on cutlery surface, scratches in metal cutlery, then marks in metal cutlery, gas porosity in metal cutlery, and dirt on cutlery. For the poor polishing on cutlery surface, poor polishing is probably the most common quality defect in metal cutlery. Poor polishing on a metal spoon, fork, or knife can be seen as excess polish or inadequate polish on the item surface. Some defects in metal cutlery areas may appear dull, while others have more of a sheen. The polishing process for metal cutlery is occasionally conducted manually by workers and often by automated machines at factories as well. Reworking poorly polished cutlery. Often all it takes to fix the problem is buffing out excess polish or applying more where the surface is inconsistent. Metal polishing equipment may be needed to more effectively polish an item, and it's often better for any polishing issues to be resolved at the factory, rather than later when goods have already shipped. Scratches in metal cutlery. Scratches are a surface defect that can lead to both dissatisfied customer and product returns if severe enough or if found in high quantities of an order of cutlery. Although scratches are often hidden by effective polishing, defects in metal cutlery are often caused by rough handling during the production process. Scratches can also appear due to inadequate packaging. Preventing and correcting scratches. Scratches can usually be prevented by careful handling of the finished product, but scratches can also occur in transit if there are issues with the product's packaging. One way to assess packaging is through pre-shipment product inspection, various on-site checks and tests such as standard carton drop test can show how well packaging will resist damage caused by normal conditions and handling during shipping. Normally, scratches found in the finished product are dealt with by polishing. Polish can remove the appearance of most minor scratches in the surface of the cutlery. But if scratches continue to be a persistent issue in finished cutlery, management at the factory may need to look closely at how the product is handled to determine and address the exact cause. Dent marks in metal cutlery. Dents are typically caused by poor molding or annealing techniques at the very beginning of production or by being forcefully impacted later. During annealing, the early rectangular blanks of metal are subject to high heat, which defects in metal cutlery toughens the metal and helps prevent bending and dents in the finished product. If the temperature is not accurately controlled during annealing, the cutlery can be vulnerable to surface defects like dents during the molding process. Another possible cause for dents and similar defects in metal cutlery is the use of substandard materials for production. It's sometimes recommended to conduct composition or other lab testing to verify materials, particularly if finished cutlery is coated in a precious metal such as gold or silver. Remedies for dents in cutlery. Dents in cutlery can be difficult to remedy. There's typically no way to remove a dent from a fork, knife, or spoon, and dents are usually too large to be concealed by buffing and polishing. If dents are a common issue with cutlery produced at a particular factory, production processes should be checked closely to verify they're not faulty. Materials may also be tested to be sure they're appropriate for that product. Gas porosity in metal cutlery. Small holes can sometimes appear in the surface of finished metal cutlery that was manufactured using sand casting, sometimes called sand holes. Due to their sand-like appearance, they are often caused by G defects in metal cutlery as porosity. Gas dissolves in the liquid metal and then rises to the surface and forms tiny bubbles in the casting as the metal cools. The porosity tends to weaken the affect the area, preventing gas porosity. If the holes in the metal caused by gas porosity are small enough, it's often possible to hide their appearance by polishing. But gas porosity on a larger scale that affects many units in an order of cutlery is a more serious problem that can often be prevented. The most effective way to prevent gas porosity is by limiting the molten metal's exposure to the atmosphere, typically by first melting the metal material in a vacuum or melting the material in an environment of low solubility gases like argon. It's also possible for air to be introduced by turbulence caused by pouring the material into the mold, in which case the mold itself may need to be streamlined or otherwise altered. If gas porosity is a repeat issue with the cutlery that you import, talk to the representative at the factory to see what measures they take to prevent it. Dirt on cutlery. Unless it can be easily removed, dirt is typically classified as a minor defect, regardless of the type of product inspected. But frequently, finding dirt on finished cutlery may be an indication that a supplier is careless when it comes to handling the product. Dirt found on a product may also be introduced at some point later in the supply chain, such as shipping. It helps in such cases to make sure important packaging QC checkpoints are followed to ensure quality packaging prevents dirt contamination. Keeping cutlery clean. Aside from keeping dirt from a product with adequate packaging, finished cutlery should be checked for dirt before shipping. Any dirt found should be washed or wiped away prior to packaging.
So the conclusion, cutlery is something that is part of many people's everyday lives, and the process used to create the silverware we use daily is a fascinating one. The process of getting cutlery from the factory to the home is surprisingly involved. From rolling to buffing and everything in between, there are many steps and quality checks. Whether using stainless steel or sterling silver, it is a story about changing technology and tastes. So next, here are the reference we use to make this slide. And the appendix, we have two. First, appendix A, types of cutlery, and B, appendix B, graph of weight required to deform cutlery. Okay, first, appendix A, types of cutlery. Here we got some numbers. It's quite blurry, but it's okay. The numbering is ascending from left to right. So there is a few types of knife, fork, glass, spoon, and plate. First, we have bread plate. Second, this one is butter knife. Next, coffee saucer. Next, a coffee cup. Number 5, place card. Number 6, dessert spoon. Number 7, dessert knife. And number 8, this one, cake fork. Number 9, water goblet. Number 10, red wine. Number 11, champagne flute. Number 12, white wine glass. 13, sherry glass. 14, napkin. 15, salad fork. 16, fish fork. 17, dinner fork. 18, service or dinner plate. 19, soup bowl. 20, salad plate. 21, salad knife. 22, meat knife. 23, fish knife. 24, dinner spoon. And 25, soup spoon. Correct. The next one is appendix B, graph of weight required to deform cutlery. Correct. This is the graph. There is 3 types of substance. First is PS, PP, and natural tape. This graph compares the stiffness of cutlery made from the new formulation with PS and PP cutlery. PS cutlery is typically stiff but too brittle, while PP cutlery is typically strong yet too flexible. In contrast, the new natural text formulation is both stiff and strong. Right, that's all from us. Thank you.